The second fundamental theorem of calculus states if f is continuous on a to b and f of x equals a to x f of t dt, then f prime of x equals f of x on a and b. So example 7 says find f prime of x times the derivative of the integral from 2 to x of 7t squared plus 1 dt. And so basically you're going to substitute in x for t and then multiply by the derivative of the variable you're given. So you would just write 7x squared plus 1 times the derivative of x, which is just 1. So your answer will just be 7x squared plus 1. And special case number 1, what if the upper limit of integration of a variable expression other than x? We must use the chain rule. And since the derivative of x cubed is 3x squared, you would just write 3x squared times the square root of 1 plus cosine, and plug in x cubed for t, and you would get x to the 6th, cosine x to the 6th. And special case number 2, what if the variable is the lower limit of integration? We must use the properties of integration to switch the limits of integration. Say that a lot. Basically, we're just going to flip it around, and when you flip it around, you make a negative. So you would get negative 1 to x, 1 over t dt. And then you would just solve it. Now you would never regularly. So plug in x for t, and since it's negative, and you got to times it by the derivative of x, which is 1. So negative 1 over x is the answer. And special case number 3 is what if there are variables in both? So lower and the upper regions limits of integration. Use the properties of integration to split them into two integrals. So since this is, again, it's in the lower limit of integration, you just flip them around and you get negative 1x, 1 over t dt plus 1 3x, 1 over t. And since you already know this one's negative 1 over x, plus you get 1 over 3x times 3, because you're taking the derivative of 3x. These will cancel, you get negative 1 over x plus 1 over x equals 0.